Hello, I am Ever Berman, and today we are going to be talking about Bayes' rule. As a bit of an overview, we are going to contextualize Bayes' rule, we are going to define Bayes' rule, we are going to motivate the definition through an example, and then we are going to make connections and summarize. As a bit of an introduction, Bayes' rule is a tool to relate the probability of A given B to the probability of B given A. Formally, we have A and B are events. The probability of A given B is equal to the probability of B given A times P of A divided by P of B. As I will expand upon later, this comes from the multiplication rule for conditional probability applied twice to get the desired relationship between A given B and B given A. So now we are going to motivate this definition through an example. So question, what is the probability of having two girls given at least one of your children is a girl? Suppose that each child is equally likely to be a boy or a girl born. Well, for a solution, we have let A be the event that you have two girls, let B be the event that at least one of your children is a girl. So we have P of A given B, representing the probability that you have two girls given at least one of your children is a girl. We start by calculating P of A. What is the probability that you have two girls? This is 1/4 because there are 4 outcomes. There's girl, 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 boy, boy, girl, and boy, boy. And so there's one of the desired outcomes in our event space. And note that a boy and then a girl is distinct from a girl and then a boy, and that we're relying on the fact that each child is equally likely to be born a boy or a girl. For the probability of B, the event that at least one of your children is a girl, well, that would be 3/4. There are 3 ways this could happen. You could have a girl and then a boy and then a girl, or a girl, girl. And then there's also a fourth in our event in our sample space. That would be boy, boy. So this is 3/4. And now we conclude with what is the probability that at least one of your children is a girl, given that you have two girls? Well, that's 1. If you have two girls, at least one of them must be a girl. So we have everything we need to plug into Bayes' rule. We have 1 times 1/4 divided by 3/4, then we get 1/3. And maybe this should make sense because if you think about all the sample space of having at least one child be a girl, there's girl, girl, and girl, boy, and there's only one of those where you have two girls. So why 1/3? Why not 1/2? Well, we've calculated the third through Bayes' rule, and we went through the sample space. But observe that the question states that at least one of your children is a girl. It's very tempting to say that child 1 is a girl, child 2 is 50% chance of being a girl, so the answer is 0.5. However, there is a flaw in this logic in that it does not necessarily have to be the older or any in particular child to be the girl. You can have child 1 be a girl, and child 1 be a boy rather, and child 2 be a girl. Bayes' rule is a great tool for tackling problems like this because instead of struggling to properly define sample and event spaces, we may just observe that P of B given A is equal to 1. That's very easy to calculate. And then we can just do much easier calculations with P of A and P of B. So as I said, we're going to talk about the multiplication rule for conditional probability. We know that P of A given B is equal to P of A and B divided by P of B. So if we apply the multiplication rule for conditional probability again, we can take P of A and B, turn it into P of B given A times P of A. And from there we get P of A given B is equal to P of B given A times P of A divided by P of B. So what have we done? We have introduced and defined Bayes' rule. We went through an example, and we connected Bayes' rule to the multiplication rule for conditional probability.